we want to look at what is considered the rational zeros. And when we're looking at rational zeros, first we need to talk about what are rational numbers to begin with. And so think about the fact that rational numbers are things like -3, a 5, even a -1/3, a 2/9. Any of these are rational numbers. Irrational numbers would include things that are like the square root of 4, not the square root of 4, sorry, the square root of 2, maybe a 1 minus the square root of 3, things that have the square root in them, or things that have, mainly the irrationals that we're going to be talking about are the ones with square roots. We also have the non-real zeros. Those are the ones with the i's. So maybe we have a 3 plus 2i with a 3 minus 2i. Or maybe we have a -6i with a positive 6i. Okay, so we're going to start out by looking at the rational zeros. Those things that when we factored, we can actually solve and get rational, real zeros. Well, there's something called the rational zero theorem. And with this rational zero theorem, we can find all the possible real zeros. So the rational zero theorem, what it's going to do is it's going to give us a list of all possible, now key term, possible, real, rational zeros for a particular polynomial. This is not going to include our irrational or our imaginary non-real zeros. This is strictly going to give us those rational zeros. And so what this theorem is going to do is going to take our factors of our constant which we're going to label with a P, and the factors of leading coefficient. And we're going to label that with a Q. And so the list of our rational zeros, possible rational zeros, is going to be P divided by Q. All of our factors of our constant divided by all possible factors of our leading coefficient. Now, whenever we talk about these, we're talking about all positive, negatives, everything, okay? So let's look at a couple of examples of this, and let's start off with if we have the polynomial of f of x is equal to a 6x squared plus 13x minus 5. Well, we could factor this, but let's just start by listing all possible rational zeros. And so what we have to do first is we have to find all of our factors of our constant, and we have to find our factors of our leading coefficient. So the factors of our constant is our -5 here. So the factors of that constant, well, factors of 5 are 1 and 5. So we could have a +1, a +5, a -1, a -5. Don't forget the positive and negative version of every single number. My leading coefficient is a 6. So the factors of a 6 are a +1, a +6, because 1 times 6, a +2, a +3. Then I have the negative version of every single one of those. So notice I have a lot of positive and negatives here. Now, to find my list of possible rational zeros, since I have positive and negatives, I could list these out as +1, +5. I could list these out as +1, and I'm going to put these in order to make it a little bit nicer, +3 and a +6. What I'm going to do is remember that my possible zeros are p divided by q, so I'm going to take 1 and I'm going to divide it by every single one of these factors of my leading coefficient. So I have +1 divided by a +1. 1 divided by a 2. A 1 divided by a 3. And a 1 divided by a 6. And then I'm going to do the same thing with the 5. So I'm going to do 1 divided by, I'm sorry, that should be a 5 divided by 1. And so, let's see here, 5 divided by 1, 5 divided by 2, 5 divided by 3, and a 5 divided by 6. And then I'll simplify these as much as possible. So I get 1 divided by 1, which is just a 1. And this one can be simplified into a 5. So I get a positive negative 1/2, positive negative 1/3, positive negative 1/6, positive negative 5, positive negative 5/2, positive negative 5/3, let's see, that should be a 5/3, and a positive negative 5/6. These are all of my possible rational zeros. Does that mean that these are all zeros? Well, no. I'm only going to have 2 zeros. But these are the possible zeros. If it is not in this list, such as a 4 or a 7 or a 1/8, it is not going to be a zero of this function. That's the nice thing about this rational zero theorem, is if it's not in the list of all the possible zeros, rational zeros, it can't be a zero of this function, provided we have done it correctly. Okay? In the next video, we'll do some more examples of this and practice some.